So continuing with our trig unit, we're going to continue to look at how do we find missing sides and missing angles. A lot of what we've been doing so far has been just making ratios. Now that we have the ratios down, we're going to see how we can use that to solve for missing parts of triangles. And as we are doing this, we're going to get into some word problems, which are going to deal with things called the angles of elevation and the angle of depression. So if I'm thinking of an angle of elevation, maybe some key words here I'm thinking is I want to look up. Okay, normal eyesight, I'm going to be taking a look up. Typically these are found inside the triangles. So if I'm looking at a triangle, I'm going to see the angle of elevation inside the triangle. And we'll see as we go through and do some word problems. So on this picture to the right, if I'm looking at the person standing at B, their normal line of sight would be out. And they have to tilt their head up so that they could see the person up at A. So this down here that we just traced out, this is going to be your angle of elevation. Okay. Angle of depression, I'm thinking, okay, let's look down then. And a lot of times when we do this in word problems, these tend to be outside the triangle. And again, we'll see how this takes place in some word problems. So if we look at the person standing at A, their normal line of sight, normally they look straight ahead. But now they have to tilt their head down so that they could see the person at B. So this here would be considered your angle of depression. So let's try a couple problems. We have here the angle of elevation from a point on the ground 300 feet from a tower is 42 degrees. Okay, so when we're doing this, we got to draw a picture. Typically, we're thinking triangle, a tower, a building. That should be your vertical line. So if that's our tower, that's going to be vertical. You might even want to say that's your tower. Okay. Hopefully, if your building is built correctly, it should be perpendicular to the ground. And it says the angle of elevation from a point on the ground 300 feet from the tower. So if this is our tower, here's our point 300 feet away. And since it's an angle of elevation, that means there's somebody over here standing and they have to look up to get their angle of elevation to see the top of the tower. So notice how that is inside the triangle. And what it's saying to us is, okay, so how big is the tower? All right, well, if we look at the triangle and we label our sides according to the angle that we have, x becomes opposite, 300 becomes adjacent, and that's going to set us up to use our tangent ratio. So we know we have the tangent of your angle is equal to the opposite side over the adjacent. Okay, so now we get to solve this. Anytime you have fractions like this, I always think put this over 1 and we can cross multiply. So that gives us 300 times tangent of 42 is equal to x. So to get our x value, you just need to enter this into your calculator. Your trig buttons are right next to the number 7. If you press trig, you get your whole list. And notice there's a couple to choose from. We want regular tangent. See how we have a tangent -1? I want regular tangent. And I'm going to type in 42, and I am going to exit out of the parentheses and type times 300, enter, and that's going to give you our answer. A different way, I like to actually enter it the way I wrote it, which is typing in the 300 first, then getting my tangent button, and then typing in 42. What that's going to do is avoid that you need to remember to get outside of the parentheses so it multiplies everything correctly for us. So we get the answer 270.121, and it's asking us, it actually doesn't give us where to round, so if we just round it correctly, which would be that 270.121 feet, we would be good. Okay, try another one. So on number 2, we have an airplane at an altitude. Okay, if I stop there, typically airplanes are up in the sky. So I'm just
Would Audrey DeWitt, please?
So we have P for plane, and it's at an altitude. Altitudes are always measured with a perpendicular line to the ground. So if that's an altitude, it says an altitude of 1200. Okay. And now it's saying the angle of depression. So that's telling me, okay, think normal line of sight. And we said depression, I need to look down. So this angle that we just created, that's your angle of depression. And it measures 28 degrees. And we have to find the distance from the plane to the building. Okay. So if we're looking at this, I want to find the distance right here. Here's my building. I want to find the distance across. Okay, something to keep in mind is when we are looking at this, I don't have an angle in the triangle. We had said the angle of depression would be outside of the triangle. Well, if I know that my normal line of sight is parallel with the ground, these two lines are parallel lines, so that would make this angle an alternate interior angle, which would give us now an angle inside the triangle, because I know alternate interior angles are equal. So if I start to set this up again, I'm looking at my triangle. I see here's my side opposite the angle of 28. I see here's the side adjacent. And then now, again, that's going to allow us to solve using tangent. So I have the tangent of 28 is equal to the opposite side over the adjacent. And again, we're going to cross multiply, putting that over 1. So now I have x times tangent of 28 equals 1200. And I want to get x by itself, so I want to think divide each side by the tangent of 28. So in order to get x, I have to type this into the calculator, so we need a fraction. Okay, so first thing I'm going to do is control divide, get our fraction template. We're going to type in 1200 divided by, we're going to get our tangent, regular tangent, and our angle this time was 28. And I press enter, and it gives us 2,256.87. So I can say our x that we're looking for is 2,256.87. Oops, you're in meters on this one. Now, we saw on the calculator we had different functions. We saw those negative ones. What those are called are inverses. So we have inverses of trig functions. And the big thing that we need to remember is when we use what? We use that inverse, the negative 1, to find the measure of an angle. Okay, so far we've been using the regular functions and we were finding side measurements. We use the inverse functions to find the measure of an angle. Ratios are still the same. Setting up the problem is still the same. It's just how we're going to enter it into the calculator and what it's going to look like when we write it. So started off the same way. According to angle A, I can see that 13 is my adjacent side. I can see 20 is my hypotenuse. So adjacent, hypotenuse, that's going to leave us with cosine. So it's always the function cosine of your angle is equal to the adjacent over the hypotenuse. Okay, so I want to find A, so what do? We're going to use that inverse function. And in your calculator, this is what we're typing in. The inverse cosine of 13 over 20 will equal the angle. Okay. So we go to the calculator, and the inverse cosine, we're going to get the same place we got the other ones. We're going to go cosine, and we're going to get our fraction template, and we have 13 divided by 20, and we get 49.4584. So what that found is our angle. So we can go back to this problem and say our angle A, and if we round to the nearest degree, is about 49 degrees. Okay, so the inverse function will find that angle. Okay, so over here on letter B, again, I would start the same way. So 40 is our side opposite, 42 is the hypotenuse. So now we're going to be using our sine ratio. So we have sine of angle B is equal to the opposite over the hypotenuse. So in order to solve for angle B, I have to use the inverse function, and I need to know that ratio, 40 over 42, which will give me B. Okay, so we go back to the calculator, and we're going to get our inverse sine, and again, we're going to get our fraction template, and this time we're going to enter in 40 divide that by 42, and we get 72.247. So now if we round, because it's saying nearest degree, we can find that our angle B is going to be about 72 degrees. Okay, so if we were to apply this to some word problems and see how this works. So we have a 14-foot ladder is used to scale a 13-foot wall. Okay, so again, if I have a wall, hopefully our wall is nice and straight, I'm going to label that as 13. Keep in mind that would form your right angle. We have a ladder that's leaning against that wall, and they've told us our ladder is 14 feet. And they want to know at what angle of elevation, so again, it's going up, it's at the bottom of the triangle, so I'm trying to solve for this. It says, must the ladder be situated in order to reach the top of the wall? So if we label our sides according to x, this is always the hypotenuse, 13 is going to be the side opposite. So our opposite and hypotenuse is going to give us sine. So we have sine of x is equal to opposite over hypotenuse. And again, we're looking for the angle, so that's telling me I need to use that inverse function. Once we enter that into the calculator, that is going to get us the angle. So if we go to the calculator, and we're going to get our inverse sine function, and we have a fraction, so we're going to get our fraction template, and then we're going to enter in 13 divided by 14, and that's going to get us 68.21. And this one says it has to, actually it doesn't give us where to round, so as long as we round correctly, so if we rounded it at 68.2, fine. 68, fine. Either way, we're going to find that angle. So I'm going to write it down as 68.2 degrees. That's going to get us to the nearest 10. Okay, and our last one. This is a two-part question. It says, standing on a cliff 380 meters above the sea. So typically, again, a cliff is going to be a vertical line. We have 380 meters, and we're standing up here. It says, Pat sees an approaching ship and measures its angle of depression, obtaining 9 degrees. So Pat would normally be looking here. Pat now looks down, and he sees this ship. And in order to find that ship, it said he had to look down 9 degrees. And the first question that we have to do is figure out how far from shore is the ship. So here's shore. Here's the ship. We need to know how far it is. Okay, first things first, we got to get that angle inside the triangle. So again, there's my alternate interiors. I know that that angle is 9. And if we look at the picture, according to 9, 380 is opposite, and x is going to be adjacent. So opposite, adjacent, that gives us our tangent ratio. So we're going to have the tangent of 9, so notice we have an angle this time, so I'm not using an inverse function, is equal to the opposite over the adjacent. Okay, so if we cross multiply, so we get x times tangent of 9 is equal to 380. If we want to solve for x, so I have to divide through by tangent of 9, and I can find x is equal to, when we plug that in the calculator, okay, so we need a fraction template, and we get 380 divided by the tangent of 9, and we can see it's around 2399.23 feet. Okay, so we're going to say about 2399.23 feet. Okay, so now part B is saying, okay, so now Pat sees a second ship beyond the first ship. And it says the angle of depression of the second ship is 5 degrees. How far apart are the ships? So you have to think, if his angle of depression is only 5, he's not looking as far down. The tilt of his head is not as far down as it was to begin with. So now notice what happens. The ship, the second ship, is now over here. So that gives us this angle at the bottom to be 5. And now it's saying, well, I want to know what the distance is. Really, I'm trying to find the distance between these 2 points. I'll call that y. In order to do that, however, what I need to do is think I need to find this whole distance first, which means I have to use this great big triangle. So if I were to redraw just that triangle down here so we can see what we're looking at, I have 380 for the cliff. Our angle is down here at 5. I'm going to label this Z. So we still have an opposite side. We still have an adjacent side. We're still going to be doing tangent. So the tangent of 5 is equal to opposite over adjacent. And when we cross multiply, we get x tangent of 5 is equal to 380. Divide through by that tangent of 5. And once we plug that into the calculator, we are, ooh, I should have used Z. Let me change this so that we're not confused. That's a Z. And over here, this should be Z because that's what we're solving for. So what we've just found is Z is really 1944.194. I plugged that in the calculator. I hope you can trust me on that. But now notice what we found. We found that whole side. I just want this little part right here. So in order to get that, if I know the whole length and I want to find just that little part, I want to subtract them out. And actually what I just did is made a great big mistake and I gave you that final answer. So let's try this again. So if I were to calculate Z, let me tell you what Z actually is. Z is actually going to be 43.42. Now if I subtract them, so now I'm going to take Z minus X will give me Y. So 43.42 minus my X will get us that final answer that I tried to give you earlier. And what that has just found is that value of Y. That's the distance between the 2 ships. That's a more challenging problem. We will be working on those in class most definitely. Please come see me if you have any questions. We will work on this, and let's get used to using the calculator. Again, if you turn your phone to the side so it's horizontal, you will see all of those inverse trig functions. And again, just like we said with the other stuff, you have to enter it in almost backwards, typing in the angle first, and then you would hit that inverse trig function to get your value. We can work on that in class as well. Okay, hope this helped. Hope you guys have a great day.